Welcome to Bio 282. This is Biolog procedures for online learning. This video is meant to be paired with the other tutorial videos posted on Blackboard and also with the reading in your lab manual. The first thing that we do in the lab is that we want to calibrate our inoculating fluid in a turbidimeter. The turbidimeter shows the transmittance of light through a solution. Here I have inoculating fluid B. Most species are going to use inoculating fluid A. However, some, such as strongly reducing species, encapsulated species like Aeromonas, Vibrio, and spore-forming gram-positive rods, will need inoculating fluid B. Here I am moving the dial on the blank inoculating fluid B to be at 100% transmittance because it should have no particulates inside. I'll double check my math and put it back in and make sure it is at 100%. Next, we'll inoculate another blank tube of inoculating fluid B with some cells from our most recent T-streak isolation. So remember, we're pulling bacteria from the most diluted area of our T-streak because that's the most probable area of having a pure culture. Here, Rachel is instructing Claire, another student, on how to collect roughly 3 millimeters of bacterial growth. And then she'll inoculate it into her blank inoculating fluid B, give it a swirl, and then she will invert it several times to make sure the cells are equally distributed throughout the solution. And then she wipes it off to make sure that no fingerprints are on the tube, which can interfere with the transmittance. So it looks like she's still at 100% transmittance, which means there's something wrong, and she needs to add more cells. So after some troubleshooting, Rachel was able to get it at 95% transmittance. After your tube is at 95% transmittance, you're ready to pipette. But not quite. Dr. Miller isn't wearing her safety glasses. When we're pipetting a solution such as this, we need to make sure that the white part of our pipette is completely sterilized with ethanol because we're going to be inserting the length of the pipette into the tube, which is something we normally try to avoid. Going down to the first stop on our pipette plunger, we'll put the tip in and then release the plunger to lift up the solution into the tip. When we're dispensing into the wells, we are also only going down to the first stop on our pipette. Notice how my pipette tip is actually on the edge of the well, resting on the edge and not going inside. This is because there is a suspended dry powder in each and every well. So if we were to touch our pipette tip in one well, we would increase the probability of contaminating the next well. At the end of one row, I'll dispense my fluid and then I'll get rid of my pipette tip and clean it out for a new one. The reason why we do this is because solution will get caught in our pipette tip through capillary action and it will lead to inaccurate levels being dispensed in our solution, in our wells. After all 96 wells are filled, you need to incubate at your microbe's optimal temperature that you have previously established for 24 to 48 hours. This is what a typical plate will look like after the incubation period. Here you can see some dark purple wells, which indicate a positive reaction, and then some lighter purple ones, which are considered quote-unquote borderline, and then the clear ones represent no chemical reaction. The information from these plates are put into a software that's specifically designed by the Biolog company. So here I've set all of my wells to positive because there's more positive than there are negatives, and then I'll select the negative option and click on the wells that are negative. So I'm working backwards to save time. At the end of clicking on all of the wells, then you'll get something like this. So here in your results, the first column says probability, and it's in a decimal, 0.999, which means 99% probability. And I can see that the first species listed is Proteus mirabilis, which means that Proteus mirabilis is a 99% probability of being the species that was dispensed into each well. Not all of you are going to have such accurate readings and have a 99% match, and you'll have to go through the other species listed and record the probability and refer to your other metabolic tests that you've conducted in class to determine your bacterial species.